Okay, let's look at the obtuse triangle. Oh, that was weird. Area formula. So I'm going to draw my obtuse triangle. And I'm going to show that perpendicular measurement there. This is my base of that obtuse triangle. I'm going to call that L. The height, the distance, perpendicular distance to the opposite vertice, I'm going to call that H. And then I'm going to name the space right here that I had to move out to the left in order to measure the perpendicular distance, X. And now I'm going to color code these triangles. So I'm going to say I have this giant triangle right here, which is a right triangle. And that right triangle has a base of x plus L. So this giant right triangle is x plus L base W. And then I have that piece here that's missing. And that triangle, I'm going to draw it over here, has a base x and a height W. Oh, I'm just going to call that W. Let's go back and call this W. Okay, and then I have my obtuse, my orange obtuse triangle, which is here, and that's an L, W. Okay, now what is the relationship of these three triangles, just like it's a composite figure? This giant green triangle equals the orange triangle plus the blue triangle. Or I could say my obtuse that has dimensions L and W equals the giant green that is a right triangle with dimensions x plus L and W minus the blue, which is that tiny piece right there, x and W, also a right triangle. And those are 1/2 x plus L W minus 1/2 XW. That's the area formulas for those two triangles. And then we have area of the obtuse. And then we can distribute the 1/2, distribute the W, and we get area of the obtuse is 1/2 XW plus 1/2 LW minus 1/2 XW. And then what happens to these guys? That is the exact same term, and we have just proved that the area of the obtuse triangle equals 1/2 times its base length times the perpendicular distance to the opposite vertice, W.